Hello everyone, my name is Siar Faiman. I am the AAC Steel Bridge Design Captain for the UTA Arlington Student Chapter for the 2023-2024 academic years. In this section of the video, I am going to talk about the different design phases for our steel bridge from the preliminary stage till the end product. With that being said, I'm going to move on to our first design software, and that is AutoCAD. AutoCAD was mainly used for all our collaborations and drafting within the team. The team came up with different design ideas, and then we choose the best one that aligned with our goals. It is important to mention that the overall configuration of the bridge was carefully chosen to strike the perfect balance between construction efficiency, aesthetics, and stiffness. What we had at this phase of the project, we took it and moved on to the next phase for our design, and that is structural analysis. For this phase, we used Reset 3D. It helped us to find our ultimate capacity. It helped us to find all the flaws for the bridge, and also helped us to reinforce those areas. The software also helped us to get our deflection values, which was very important for us for the structure. What we had at this phase, we took it and moved on to the next phase. In this phase of the project, we used all the spreadsheets we set up earlier to get our buckling design, and also our bolt design, which is also another crucial step for the design phase. After the bolt design and buckling design was done, we moved on to our connection design, which is also another important step within the design phase. After we were done, we moved on to the next phase of the design, which is 3D modeling and shop drawings. For this phase of the project, we used Fusion 360, and it helped us to have a perfect understanding of the bridge and how everything is going to look like. After we were done with the 3D model, we used Fusion 360 to also create our shop drawings. Shop drawings were really important for us because we needed them for the next phase of the project, which was fabrication, and all the fabrication was done within the house.
Hello everyone, my name is Aryan Padania and I'm the current project manager of UTA Arlington's Steel Bridge team. Fabrication this year, one of the key emphasis that I put on the team was to invest in creating a jig. A jig is a wooden surface that can hold the metal pieces together just so that we can tack weld it. So what this does is that it ensures that every single repetitive piece that we have is neatly cut, and it also means that all of our pieces will be super identical. The entire fabrication period will be shortened in a significant manner because we will have the templates to produce those. And once that was done, we load tested our bridge, and for load testing we just went a few 100 pounds over the actual limit that we have to place on the bridge, and we measured the aggregate deflections at both ends. The one thing that we kind of kept in mind at all times was the assembly. And for assembly, we thought about a lot of innovative ideas, as we did for fabrication as well. And we thought about producing a bridge that can be constructed the fastest. So for that, we initially didn't want to use a barge, but then we realized that the river span is way too long and it is super dangerous to not use a barge. So we ended up using a barge, and the entire point was to just make sure that one end from the footing to the other end of the footing is connected first, so the one entire stringer side is freestanding, and after that we add the cross members and also the second side. So that way the entire bridge is freestanding, and then the tension rods will be added on the bottom. So this ensures that the bridge assembly can be achieved quicker, and also make sure that we do it safely, and also that we have fewer drops and fewer accidents along the way. And that is basically the overview of what the bridge looked like and what we had to do to get to where we are right now.